So I will start to discuss with the discussion on the quiz that we have just now. Okay. Any of you here having any problem with the quiz?
Angle, Pak. I am a little bit confused about the angle.
Which angle?
When you find AD,
80. 80 here is 60 degrees, right, from the horizontal. Uh,
yes.
which angle that you are confused? You're confused about?
So to in order to find AD, we need
Mhm.
to rotate it to be perpendicular right to the point D.
And of
I mean
this is
to the
really you,
CH.
you you can just use the AD here. AD. So basically, AD is a two-force member. Asad,
Yes.
yeah, EF is two-force member. So basically, those two are the most important thing. So the first free-body diagram that you're supposed to solve is the
The
FHG there.
FHG. Yes.
Yeah, to find out for HXHY and FEF, right?
Yes.
Have you solved that?
Uh, I didn't solve the HYHX, but I put the moment at H so I
Hmm?
can get FE
Okay,
immediately.
you can get FE, but the problem is HX and HY will be useful for you to solve for AD. You get it, Asad?
I'm sorry, Pak. Oh, solve to
H,
you used to solve AD.
yes, correct. So, okay, I think I will just discuss this particular problem. Actually, in order to solve this, the first thing that you're supposed to do is to understand the problem. After you understand the problem, then the next thing that you have to do is uh, to analyze which member is two force member. In this case, we have two members, which is two force member. This one, EF and AD. Okay, those two member are two force member, and uh, basically those two are the one that is being questioned as well. EF and AD. Okay, in order to solve this, we have to solve several two-sided diagram. Okay? By analyzing the whole things, you can see that there are several two-sided diagrams that is supposed to solve. Okay, sometimes you can try
Okay.
to some of you may try to solve the CH directly. Remember CH directly like this. Okay, CH. CS there we have HX and HY. Okay, CH there we have HX and HY. Beside that we have EF here at this particular point here at this point right? FEF. Then at point D here at this we have a FAD like this, and at point C we have CXY. Okay, this is the member CH. All the unknowns are there, A, D, E, F, right? But the problem with this is we have too many unknowns there. It's X, H, Y, F, A, D, F, E, F, C, X, A, Y. So six unknowns, we cannot solve it directly. That's why instead of solving CH, we have to solve for FHG first. Okay, we have to solve for FHG first. For FHG, so this is the free body diagram. Okay, for FHG, I will not care about the two force member inside of that particular things. Okay, so I will consider that as part of the system. So this is the whole system. So this one, I will consider this two force member as part of the system. Okay, for this particular member, we have a G. Okay, the value there is supposed to be 1,250 50 kilogram times the gravitational acceleration. So it's supposed to be 12500 K. Okay. Actually, it's not supposed to be 00, but multiply by 9.81. Okay, Newton. And beside that, we have Hx and Hy at this particular point. Hx, Hy. And beside that, we have FEF there. Okay, you can assume anything. You can assume tension or you can assume compression. There. Okay, for this particular free body diagram, it can be solved. You can solve it because we only have to solve three unknowns and we have the equation as well. Sigma fx equal to 0, sigma fy equal to 0, and sigma moment equal to 0. So you can solve this. Like what Asar said just now, okay, you can solve for FEF by using a sigma moment at point H. But the problem is you cannot just go to the next free body diagram. So if we consider this as the first free body diagram and this one is the second free body diagram, okay, we cannot go to the second free body diagram without solving Hx and Hy. Because if you take a look at the second free body diagram, we have 6 unknowns.
So we have to search the Hy and Hx in order to be 3 equations.
Yes, correct. Asar. So you have to solve for FEF, yes, in order to get this. You have to solve for FEF here in order to get FEF here. Then you have to solve for Hx and Hy in the first free body diagram in order to get this and this. By doing so, later in the second free body diagram, okay, instead of 6 unknowns, you will only need to handle 3 unknowns. And after that, you have the equation as well. You get it, Asad?
Yes, sir.
So basically, that's the way to solve the problem. Okay, so basically, that's the way to solve the problem.
So sir, I
Mhm.
want to ask.
Okay.
So in the if I want to search for Hy. So
Mhm.
mm, do I have to cos 10 degree again? Because the plane is a little bit slanted right there. Then
Okay. Okay. Hmm.
I
It's
I
up to you,
am confused
Asad.
about the
Yeah, it's
angles.
up to you, Asad. So yes, you are correct. Because CH, right? You mean CH here is actually slanted little bit by 10 degrees, right?
Yes, sir.
Okay. So actually you can use X and Y completely vertical and horizontal like this for H and X, for Hx and Hy. But the easiest way is to create another coordinate which is slightly slanted, like
I'm sorry, another what, sir?
coordinate,
Oh, coordinate. Okay.
yeah, which is slightly slanted, x accent and y accent.
Mm.
So later here, instead of using hx and hy, uh, we can use hx action and hy action.
Okay.
So you don't have to use hx and hy there. Um, okay. Okay, so you don't have to use hx and hy. Cx and cy, you don't have to use cx and cy as well. I can create another free body diagram there, like this. This one is my hx. This one. Why I keep doing it this way? This is my hx accent. This is my hy accent.
Mm.
Okay, same as cx and cy. This is my cx accent. This is my cy accent. Then we have FEF, FAD, FEF, okay, FAD, like that. You can use it this way. You can use this way. And the same for the first free body diagram, okay? You can use X accent and Y accent as well there. So basically, okay, G, then what else? It's XHY, FEF, okay. HX accent, this one. HY accent, then FEF. Something like this. You get it? That's that. Because uh, by doing so, the calculation here will be much simpler. Correct, right?
Yes.
Hmm. But later, the calculation here will be slightly more complicated. That's all. Okay, sir?
Okay.
Hmm. So this is for all of you guys. You can choose whatever coordinates that you want, like this or like this, okay? Uh, which will help you to solve the problem. So sometimes by choosing the coordinate, we can simplify the problem quite significantly. Okay. About the quiz, anyone having any problem? Besides what we discussed just now with Azar.
Sir.
Sorry.
Oh, never mind.
Yeah.
You go
Discuss.
first, Ajar.
No, I mean, can you go through the full with um the counting as well?
With the value.
Because
Nah. I will not go with that because
okay,
it will take too long to do that. Uh,
okay,
the things that I will explain 2 days in the class is just the process.
okay,
Because if I go with the calculation, one problem it will take at at least half an hour, right? That's the
yes,
thing. So uh, I will try to cope with more problem
okay,
than
mm,
than usual like that.
okay, but Can I cross check with you if after this class, I mean, I'm gonna count it again, recount it
Uh,
again?
I think it's better for you to try to cross check with Nando, uh, Alexander Fernando or something like that. My assistant.
Oh, so I chat him
Yeah,
directly.
yeah. Just check.
Hmm.
Okay.
Okay, Pak.
Okay, for your quiz, right? Your homework and your quiz. Normally, the one who will check those are my assistants, either Nando or Rifki Akmal or the other one. I have another assistant as well. So those three will be checking your homework and quiz. I mean, those three will be will be the one who checks your homework and your quiz.
Sir,
Yes, Matthew.
is EF perpendicular to FH?
30 degrees. EF. There, okay, SH. There. So, is there any data there about the FH? 2 meters, 3 meters, 3 minutes. Actually, it doesn't matter. Maybe it doesn't matter. It can be perpendicular, but it may not be perpendicular as well. But it doesn't matter because the most important thing is not whether it's perpendicular or not, but the most important thing is about the geometry between the angle between this and this and this. Okay, as long as the distance between all of those are there, it's supposed to be okay.
Sir, because I can't find the distance between EF to H. I used a different method for the quiz.
Wait, let me check. F 1.5 meters is there, okay. Then 30 degrees is there, okay. Okay. It's 30 degrees. 10 meters, 2.5. I think so. Seems like actually it can only be solved if the EF is 90 degrees, right? Matthew?
Yes, I think so.
Yeah. That's correct. Yeah. EF is 90 degrees there. Because actually the distance there is not okay. Degrees. Yep. It's 90 degrees. It must be 90 degrees because if not, it cannot be solved.
How do we see that? I mean, how to determine that they are perpendicular? Because there's no indications and all.
Actually, I supposed to give information to you guys that is supposed to be perpendicular. Okay, Matthew.
Okay, sir.
Oh, but like in the exam, it will be likely more information than in this question,
Yes,
right?
of course. Yeah, because this is just a quiz, right? So, quiz for the quiz, right? Quiz for me is just have a slight more grade than your homework. So it's just quite close to your homework. So it's not that big, it's not a big deal for the quiz, but for the exam, yes, of course, the information will be more complete.
Sir.
And you don't have to. I believe it's better for you to not expecting a problem from the book, right? And yeah, you can practice with the problem from the book in the exam, but most likely the problem there will be given will be new problem which is created by the lecturer, like the previous problem that you have in the previous exam. So the problem will be fine. It's not similar, but it will be for the frame and machine, but it will be new problem. Okay, so don't expect a problem that will come that will be exactly the same like in the book. But like it or not, you have to practice from the book. Okay. Yes. Anyone else wants to ask question?
Sir, I have a question.
Yes, Rafi.
So for the perpendicular distance,
Mhm.
what I did was I extended EF so that it reached the 1.5 distance. And then
What do you mean by 1.5 distance?
so so the distance between EH is 1.5, right, sir?
Yeah.
So I kind of extended EF so that the line of action would touch the 1.5 mark on the right side.
Yep.
And then I did and then I figured out the FH, well, the new FH using tan 30.
Yeah,
And
but
then
that's the only thing. I mean, yeah, that thing can only be done if, from the beginning, the assumption of this particular angle is 30 degrees. 90 degrees is there. You cannot do that without having the assumption that EF and FH creating a 90 degrees angle.
oh no, sir. I mean so the 90 degrees now becomes the H angle, the EHF.
Yeah,
So
I understand what what's the thing that you are trying to do. This is what you are trying to do, right?
correct.
So basically, you are using this particular triangle.
To calculate the moment.
Yeah. You're basically using that particular triangle. But in order to use that particular triangle, this one must be 90 degrees, right?
So whilst making this triangle, we can assume EFH is perpendicular as well.
Yeah. So, but the thing is, from the beginning, I supposed to give information to you guys. The FH and EF is making 90 degrees angle, right? Without that vertical information, the things that Rafi did just now, it won't be valid.
If we think about it, it doesn't have to be 90, sir.
Right? What?
EFH is sorry. EFH must not be. It should not be. Oh no. It can be not 90.
And then?
All that matters is the distance of EF from let's call point Z at F accent, or let's call point F accent as a new point. And point F can be located anywhere, and F accent will always be perpendicular to H. I think it's like that, sir.
F accent always be perpendicular to FH. I don't understand what you mean.
Wait, sir.
Sir, I think what Matthew is trying to say is that no matter the angle of the FG arm, that as long as we just extend EF, can the angle between the EF shaft and the FG arm itu kan it's not gonna always be 90 kan? But as long as we extend
FG arm itu maksud kamu yang ini?
Yeah, but yeah.
Mhm.
If we make the EF shaft shorter at one point, that's not going to be 90 degrees, right, sir?
Yes, 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 yes.
So I think that as long as, like, no matter what the angle is, as long as we extend EF to what do you call it, to this 1.5 meters, I think we can still find that moment using the 1.5, sorry, the height of the perpendicular distance.
The height of the perpendicular distance.
For example, we put, I don't know if
So
I
you
can.
have a 1 point here.
Yeah,
Okay.
yeah.
Then.
Mm. So no matter what the angle of the arm is,
Mm-hmm.
I think that
Okay. Then, if
uh,
this is the f axis, for example, okay. Then.
yeah. So F accent would just be an extension of EF. So
Mm-hmm.
I don't think the angle of the arm would matter in this scenario.
Why
So
not?
because apa namanya? Even if it's like let's say, I don't know, 100 degrees, we can
Mm-hmm.
still extend EF and make this one this right angle triangle, I think. If I'm
Yeah,
not
the triangle here, right? You mean this particular triangle, right? You mean?
No, I mean triangle EHF prime.
E H F E H F accent. You mean?
Oh yeah, F accent.
Okay. Degrees.
And since we're just extending the EF until it reaches this 1.5 meter,
Mm-hmm.
it's gonna be right angles. I mean, it's gonna be a right angle triangle, no matter what the arm is, I think.
Okay. Uh, no, but I mean, just now your question is whether let's see. Yeah, actually, yes, it's correct. You can do it that way as well.
Yeah, so intinya what I'm trying to say is that
Mhm.
I don't think it needs to be a 90-degree angle between the arm and this shaft.
Mhm. Okay, okay. Yeah.
H have sorry. The angle between EF H doesn't have to be 90 degrees. If let's say F is slightly to the left, so let's say EF is shorter, but the angle between the angle at E is still 30. That means the angle is not 90 degrees, right, sir?
Yeah,
The
yeah, yeah.
angle at F.
Correct. Yes.
Yeah, but if we extend the line of action of EF until F prime, we can still use sine 30 times 1.5 to find the distance between EF to H.
This particle distance, what you mean?
Yeah. No, not that distance. The distance of when we make EF into the Y component.
EF to the Y component.
Yeah, because we're trying to find the moment, right?
Oh, the F accent to H can be used for the perpendicular distance actually. But for the EF, we're gonna, for the perpendicular part of EF, I think we have to do like different thing than sin 30.
Yeah, you can't. You cannot, Matthew. So,
Okay.
but this one still can be used because this particular point, what? Actually, we can just try to extend it here, and then the calculation is based on the f action point. So that you're supposed to do. That's what you're supposed to do. Okay, because the distance, right? The distance is not supposed to be. It's not have to be the distance where it touching the things, right? FHG like that. It doesn't. The force is not necessarily have to touch the FHG, but the distance can be any kind of distance as long as it's in the line of action. That's the thing, Matthew. You're supposed to you're supposed to be very careful because just now the second assumption that you do it's only walk when it's 90 degrees. But the first one, calculation can be done by using the point F action. Yes, it can be done. Okay, Matthew.
Okay, sir.
Okay, I think
Sorry, I'm a bit sleepy.
it's okay. So I think that's all for this particular discussion. So basically, you can do the calculation without a 90 degrees angle must be given there, yes. But by doing by creating another point f accent or f prime there and use that point as the calculation for the distance of the FEF like that. Okay, I think that's all. Then I will continue our
Sir,
discussion.
I
Yeah.
want to ask. I
Yes,
want
Asa.
to in before it is 30 minutes, right?
Mm-hmm.
And it is from 10 to 10:30.
Mm-hmm.
Uh, uh can we have like so 10 to 10:30 is the pengerjaan and a 1 minute extension in case of the Wi-Fi disturb, sir, because sometimes my connection is bad and it has to be refreshed again like that.
Okay. I think for your case, right, I think just try to explain it to my assistant and it's supposed to be okay.
Oh, okay, sir.
Mm-hmm. Okay. And I think that's all for this particular discussion. And then I think we'll try to open the other one. Uh, this one we have discussed it, right? And it is in your homework as well. Mm. Oh yeah, by the way, regarding your homework, do you have any problem? This is one of your homework, right? Can you do it, guys?
This one, yes, sir.
This one
So
is
it's
supposed
a
to.
little
Sir,
bit
I
weird.
have a problem in number 1 and 2, sir.
Number 1 and 2 is which one?
I got stuck midway, sir.
The lamp and I don't know number 2.
Yes, the lamp and the person standing on top.
The cleaning window thingy, yeah.
Lamp. The lamp. What's the problem with the lamp?
So sir, if we were to, is it okay if we cut? If we use the method of cut?
Which one? The lamp. This one.
Yes, sir.
Okay.
So if we cut the points, the sections of BC and BD and CD, is it fine? I mean BD and BC, sir.
BD and C.
Sir, and FD, it will be.
And FD.
Yes.
Oh, that's a problem. That's a big problem. You cannot do that because FD is non-two-force member. Yeah, this particular FD is not two-force member. It's multi-force member. So if we draw the free body diagram of FD, right, there will be dx and dy here, fx, fy, and then at point E, there will be FAE there. The one that is the one that is two force member is AB actually. AB is two force member.
So,
FE is not two force member.
So if we cut from AB, BD, and DC, it will be fine.
AD, BD, and DC.
Yes.
You mean you do a cut like this, right?
Yes, sir. Yes.
Okay. Why you need to do cut like that?
So we can find the forces in B and C, sir.
B and C.
Yes. Because from from my logic, if we find the forces of BD.
Oh yeah. Oh, sorry. One more thing. DC is non-two force member. The same as BC. BC is not two force member because at point C here there is a friction there. So there is a moment or the input there. So DC and DC and BC is not two force member. So you cannot do a cutting method here. One thing, never do cutting method in the frame or machine because most of the time cutting method will not work there unless you are expert in mechanics, right? Sometimes you can do that, but it is very dangerous for you to do a cutting method in the frame or machine. Okay, Irfan. So never do cutting method in the frame or machine.
Yes, sir. So, sir, it's not allowed to cut anywhere there.
Yep. Don't cut.
Oh, I see, sir.
So just try to solve the multi-force member free body diagram of the multi-force member. This one, right? One of the easiest way to solve it is what I told you guys. So the first one is to solve for this this particular free body diagram. So B, D, C, and G there. So it will be like this. Okay, something like that. We have G here, right? We have G there, 6 Newton. And what else? That we have dx and dy here. Dx dy there, and we have, and we say that I have AB. This is the first free body diagram you can solve. You can use dx dy, or you can use dx and dy accent. It's up to you.
Oh, so sir, for points B, for points, wait, sir.
At point B, yes, it's FAB because AB is two force member, so you can just put AB there, FAB there.
Oh, I see. So we nggak nganggap point C ya, Kak? Ya, Pak.
Point C, yes. Point C, we include it in the system. So the system is, the system consists of this, all of this. So point C is inside of the system. That's why you don't have to put a point C forces at point C there.
I see. Okay, sir.
Okay. So this is the first free body diagram that you can solve. So by solving the XDY and FAB, then you can go for the second free body diagram here to solve for FAE. Because the X and dy can be solved from the first free body diagram like that. Okay? Is that yes?
Sir, what about the BC and DC? Both have forces, right?
Yes.
I mean, why you neglect it? Why I think
it's
why
part
do
of the
you
system.
neglect it in here?
So when we talk about system, right? Remember the beginning when we talk about equilibrium. Okay, you can choose whatever systems that you want, right?
Okay.
Okay, whatever inside of the systems, okay, we will consider that as internal force.
I'm sorry, sir.
Whatever inside of the system, we will consider it as internal force. So for this one, the one outside of BDCG, okay, will be considered as external forces plus the gravitational force. So the one that you're supposed to put in the free body diagram, remember, in the free body diagram, the one that you're supposed to draw is just the external forces, and the gravitational forces. Correct, right?
Yes.
So if I put BDCG, this particular system, as my free body diagram, okay, everything outside of it will be considered as external force. Plus, I have to draw the gravitational force as well. So the gravitational force is 6 Newton here. DC is considered as internal force. You don't have to draw it. No, you don't have to draw it, but you can't draw it because it's an internal force. You get it now?
So, in
So,
this
so the
particular
external force, the external force there, it will be the forces, the force given to the system, to the free body diagram by member AB and member FED. And this is the force that is given by member FED, dx and dy. This is the force that given by member AB, FAD. You get it?
So we can, but the angle from FAB to BC is different, right, Pak?
Doesn't matter.
Doesn't matter.
Doesn't matter.
I mean,
Because
I'm still
yeah,
confused because BC and DC should have force that help
yes, but it's internal
FB, right?
force.
So it's negligible in this full
Not
FBD.
negligible, but the problem is when I consider the system is like this, and everything inside it supposed to be included as internal force,
Okay.
except for the gravitational force. Okay, and the things outside it will be considered as external force. And the one that you're supposed to draw in the free body diagram is only these two: external force and gravitational force. Internal force is not supposed to be there.
Yes.
You
So
get
the
it?
internal didn't
The,
get
the
into the
concept,
equation, right?
yes, yes. The concept is something like this, the same as this. If you have thrust,
Yes.
if you have thrust system like this, okay, it got a force like 10 kilonewton in the middle like that. The question is, I want to find out the reaction forces at A and at B. What free body diagram that I supposed to show? The whole one?
Yes.
The whole free body diagram.
The whole thing.
In that case, I draw it like this, right?
AY, AX, and BY.
Yes. AY, sorry, this one we have AY, AX, and BY plus 10 kilonewton. Okay?
Yes.
This one is external, external, external. These three are external. Okay? Everything inside it, this, all the members there. Do I need to draw it here? Or can I draw it here? No, right?
No.
Because it's internal force. So whatever problem that you have, okay, the decision of the system that you draw in the free body diagram, okay, will determine what force that you're supposed to draw and what force that you are not supposed to draw. The one that you're supposed to draw in the free body diagram, you can only draw two. Okay, external force. Okay, external force and gravitational.
Gravitational. Yes.
Okay, now I ask you again. This one, for this particular system, BC, BD, BC, BD, and DC is part of the system. So should I draw the forces or not?
I'm sorry,
It's
sir?
internal force.
Oh, not be drawn.
Yeah, you cannot draw it. So what is the one that is external? This one is external. FED is external. So due to FED, there will be two forces, dx and dy, right?
Yes.
Okay. And due to AB, there will be one force, FAB. And another one that I'm supposed to draw is the gravitational force. This one, 6 Newton. You get it?
Oh, yes, yes. I get it. I get it.
The same thing for this one. If I want to draw the free body diagram of a member FED, so all FED, I need to draw the member FED. But the easiest thing about FED is because it's just one member, everything else become external force. Right?
Yes.
So Fx, Fy become external, dx, dy
Yes.
become external, and Fe become external. Like that. Okay?
Okay.
Now I think let's go directly because I need to, because today is the last last chance for me to teach you guys about the frame and machine. I want to talk a bit about this problem as well because it seems like some of you are having a problem with this. Okay, determine the force in cylinder AB due to combined weight of the bucket and operator. The combined mass is 180 kilogram with the center with the mass center at G. This one. So all the combined weight will be there, 180 kilograms. Okay, and the one in question is just this, FAB. Okay, in order to solve this, can anyone here tell me how to do it?
Sir, can we use cut again, sir?
I told you never use cut method in the frame or machine. Okay, Irfan, this is a frame. This is frame and machine problem or trust problem, Irfan. Hello,
Frame
Irfan.
and machine, sir.
So I told you before, right? Can you use cutting method here?
No, sir.
No, that's the answer. If we are in the offline class, right, I will come to you and give you a little hit. Okay, I'm telling you, just know about this. Okay.
Okay, sir.
Okay, Irfan. Now, please help me, Irfan. Here. Do you understand the whole problem, Irfan?
I think so, sir.
Okay, you understand the whole problem, so you know that the one in question is the forces which is happening at member AB, right?
I'm sorry, sir. Can you repeat?
The one in question is the forces at member AB. Correct, right?
Yes, sir.
Okay. Now, after you understand the problem, what is the second thing that you're supposed to do? What
The
things?
external forces, I think, sir.
No. Always follow the sequence. The first one is to understand the problem. The second one, try to find the two force member. And then pick the free body diagram to solve. Then solve. Okay, Irfan, I believe I'm telling you this over and over. Right? The first one is understanding the problem. The second one is find two force member. Now try to help me to find the two force member there.
AB, sir.
AB two force member. What else?
EFDA.
EF is not two force member. Hey, whenever you have something like this, some kind of member like this, and suddenly there is a force in the middle, it will not be two force member. Okay, everyone?
Yes, sir.
Okay, so EF is two force member or not?
I think only AB, sir.
Only AB. How about DC?
DC, sir.
Yeah, DC. DC is two force member or not?
I don't think so, sir. Isn't it the same as EF, sir?
No,
I think yes.
EF. Okay, EF. There is a force at point B there due to AB, right? At EF. At member EF. But at member DC, there is nothing there beside at point D and at point C.
Yes, sir.
So it's two force member. DC is two force member. This one is two force member as well. This one is two force member as well. This one is two force member as well. And this two force member, this one is two force member. We have a lot of two force member there. But we don't have to solve for the upper part because it will just confuse you guys. So the things that we have to solve is just the one that is close to 8. Okay, the one which is close to AB, because AB is the one that we want to solve, right? Okay, now anyone here can help me which free body diagram that I have to solve in order to solve AB. Anyone here?
Maybe EF.
From bottom until E.
EFB. Okay.
EFAB, maybe.
EF and AB, yeah, but AB will be in that particular free body diagram. AB will be external force there, right? So yes, correct. EF there is the one that we need to solve in order to solve for AB. So we have EX then EYEX. At point F we have FX, FY, and then at point T there will be FAB. Like this, right? Correct, Asad?
Yes, sir.
Okay. Now, how many unknowns there in this particular free body diagram?
1, 2, 3, 4, 5.
5 unknowns.
5. Yes.
Yeah, 5 unknowns. How many equations?
3.
5 unknowns and 3 equations.
So cannot.
We cannot solve it.
Hmm.
Okay. So, but this is the main free body diagram that you're supposed to solve. The same as this one as well. Okay. In order to solve for FAE, you have to solve for the second free body diagram here. This is the main free body diagram. But we cannot solve the main free body diagram directly, right? So sometimes in order to solve the main free body diagram, we have to solve another free body diagram first. That's the technique behind it. So try to find the free body diagram that you're supposed to solve in order to solve the problem. In this case, is to solve the member EF like this. This is the main free body diagram. But the problem here is we have 5 unknowns and 3 equations. We cannot solve it directly. So we have to find a way, okay? We have to find a way in order to solve for this. Okay? This is 5 unknowns and this is 3 equations. So as long as we can reduce two unknowns, we will be able to solve this. Okay, correct, right, Asad?
Yes.
So as long as we can reduce two unknowns here, okay, we can solve this. How to reduce a number of unknowns? By solving those unknowns using another free body diagram. Can I do so, Asad?
I think so.
Yep.
You mean make the apa tempat orangnya and the thingy right first?
Yes, correct.
And
So the
kayak
next one,
hub
but
gitu ya, Pak?
not necessarily have to be a step by step, but the next thing that you're supposed to do is the one that we can solve is actually is not the one below, but the one up uh, uh, this particular free body diagram. Those things we can solve, right?
Yes.
Okay, and by doing so, we will be able to solve for EX and EY, right?
I think so.
In that case, we can go for it. Because by solving for EX and EY, okay, if we solve for EX and EY first, now after that, this particular free body diagram will only left with three unknowns and three equations, which can be solved. Right, Asad?
Yes.
So the free body diagram that we have to solve is DEG there. So for DEG, it will be like this. Sorry, I think for DEG, it will be like this, then like this, then like this, okay, like this, and like this, a person, yeah, like this. Okay, at point G here, there will be, can you still see my
Yes.
my writing? You can still
Drawing.
see my writing.
Yes,
At point G here, there will be 1,800 Newton. Actually, it's not supposed to be 1,800 Newton. 180 kilogram multiplied by 9.81
yes.
meter per second square. Okay. Then what else do we have there? At point E and at point D.
At point E, EYEX.
EYEX, but I have to I have to make sure that EYEX is supposed to be the opposite direction of this, right? Because I draw that free diagram first, left and down. Then at point D, remember just now you told me that DC
yes,
is
the
two
X
first
and
one.
Y.
No, DC. We discussed what DC right just now. DC is two first
yes,
member,
DC.
right? If it's two first member, should I put it as the X and Y?
No.
Nope, you're supposed to put it as
External
FDC.
force.
Yeah, the same external force, but this one is supposed to put it as FDC. Because the number of unknown is different, Hasan. By putting FDC here, it's actually only one unknown step. But if you put it as dx and dy, it will be two unknowns. So you have to be careful about that. Okay, sir? So FDC, ex, ey, all the dimension is there. Can we solve for this?
Yes, two unknowns and three equations. Wait.
Three unknowns.
Three unknowns, yes.
Three unknowns. three equations.
Sir, I'm sorry, sir. My mother is calling.
Okay.
I'm
Calling
gonna
inside of.
mute. I'm gonna mute myself.
Okay. So anyone else here having a problem with this? So after you solve for this three equations, three unknowns, FTC, EX, EY, right? Then EX and EY in this particular free body diagram, we got the value from the previous free body diagram. Then now we left with three unknowns, Fy, Fx, Fab, which then now we have three unknowns and three equations, which we can solve. Anyone here having a problem about this? No one? Okay. Matthew, it's not supposed to be a problem, right, Matthew?
I don't think so.
Okay, good. Risky.
Yes, hello, Pak.
It's not supposed to be a problem, right, Risky?
No, I'm good with it.
Okay, good. How about number three? Anyone here having a problem with number three?
I do, sir. Because it seems like the
I think
joints
there's a lot of symmetry in this problem as well, right? So
Yeah, it's symmetry. Yeah, but the join, which joins that you have a problem with, Matthew?
the one at the joint at the very right only have the y direction, right?
This one.
But at the middle and the left, the joints, sir.
Join at right, you mean this one?
Yeah, that one only have
Yes,
the y
correct.
the y direction.
That one is actually this kind of joint is actually a roller joint.
Yeah, but the other two is not, right?
Yep. The other
But
two are not.
somehow the question is not stating the distance of the distance at y, so cannot calculate the moment
Why not?
between each other.
Why not, Matthew?
I don't know how to find the distance, sir, because it's not given.
Yeah, but actually, it won't be necessary for you to find the distance there. So actually, all the things actually depends on what you have. Only the vertical force only. Okay, the distance won't matter there. Sorry, the distance, the horizontal distance there for the horizontal moment there, it won't matter.
So let's say we take the moment at C, yeah, sir. The
So
free body
basically,
diagram.
yeah. So basically, you can draw it like this, right? So this is your final free body diagram that you're supposed to solve, right? I try to draw this particular free body diagram. Then, because of there is a slot here, okay, it's supposed to be vertical force due to this particular roller, right? Correct, right?
Yes, sir.
Okay, sorry. I think I just draw it downstairs, going down. Okay, going down. And what else that we have there? There is a pin here. Okay. There is a pin there. I will name it as AX. Sorry, AY and AX. And then there is a force there. Okay, the pinching force, right? P there. Okay, as long as you have this particular force value, you will be able to get this, right, using sigma moment.
Yeah. What about AY, sir?
AY? Not necessarily. You don't have to find AY. You don't have to find AX. The one in question is the hand grip P. Right?
Oh, I see, sir.
Sorry, the hand grip P. Sorry, the pinching force Q. Just using sigma moment at on A. Yeah. Using sigma moment, right? just using sigma moment at point A as stop. Sigma moment at point A equal to 0, right? We will be able to find the Q. You get it, Eddie?
Okay, I get it now, sir.
So basically, from the first free-body, this is the second free-body diagram to find the force shear, the force at this particular roller. Okay, Ry, for example, I name it. Okay, so after Ry is fine, after you find Ry, after Ry is found, okay, you will be able to find Q using sigma moment at point A using this particular free-body diagram. But you have to find Ry first. How to find Ry? Then you have to go for the second free-body diagram. This one. Okay. For that particular free-body diagram, we have it like this. Okay. So basically, it's like that. Okay. We have P here going down. Then we have a slot. We have here there is a Ry. Yeah. Then what else do we have? There will be this one because and this one as well. Okay. So basically, that's the thing that you're supposed to that's the thing that you're supposed to try to solve, right? So this is the first free-body diagram that you're supposed to solve. Okay. And this is the second free-body diagram that you're supposed to solve. But for this one, the things that you need to find is just the Ry only. Okay. And because of symmetry, I believe it's not supposed to be hard to do that. Okay. Then for this one, it's just a geometric problem. For this one is actually is quite hard as well, right? Anyone here having a problem with this? Matthew, do you have any problem with this?
Sir, for this
Sarah?
one, is the P force different for the scissors?
Between the between the upper and the lower, you mean?
Is it different? I think it's different.
No,
I still don't know.
no. This one will be exactly the same. Aaron. Is the upper one and the bottom one, it will give exactly the same P force, cutting force.
Yes. And also for the two force member, does it affect the?
Yes, of course. This one is two force member, right? Yes, correct. That one, there is one force member there. Yes.
Does it affect the upper part of the scissor or only the bottom part?
Only the bottom part.
Yes.
Only with the bottom part. So basically, there is no connection between the two force member with the upper part here. There is no connection. It's only connected to the bottom part.
But the P force is the same then, yes.
Yes, P force must be the same, because if not, it won't be in balance condition.
Okay. So, I see. Thank you.
Mhm.
Sir,
Hmm. Yes, Matthew?
If we look at the bottom handle, there's
actually that's the only thing that you can do to solve the bottom handles, because the upper handles, right, the number of unknowns is too many.
I'm trying to ask if itu ada two force member, right?
Yeah.
Tensionnya tuh towards the bottom atau upwards?
I don't know. You can assume.
I got it towards the bottom. Itu tension bukan, sir?
Wait a minute.
If we look from the first,
I believe it's supposed to be under tension. Yes. I believe it's supposed
it's
to be
a
under
bit
tension.
confusing because
No, it's
the
not
direction
supposed
of
to be.
the
It's not
member.
supposed to be and confusing. Right? So I will try to solve this as fast as possible. Okay. So this is the first free body diagram. Okay. There is a high 50 Newton. Then beside that we have a two force member here. Okay. Then we have here I call this point as D. I call this point as A. I call this point as B. I call this point as C. Okay, CX, CY. Then we have FAB like that. Okay, so this is the first free body diagram. Actually, I'm drawing this.
Yes, sir. Ini FAB itu tension atau kompresi kalau arahnya kayak gitu?
Tension. This one is tension.
So
by solving this, we have a FAB, CXY, three unknowns, three equation. So we can solve for those three. Okay. Then after that, we solve for this particular one. That one is tension, Matthew. Okay. So then after that, let me draw for this. Okay. Okay. Because it's under tension, FAB is under tension, then at point B here, where is the direction of FAB? Matthew?
Upwards.
Correct, upwards. It's supposed to be upwards. FAB. Then
itu confusing karena arah membernya weird, sir.
Nah, it's not that confusing. So at point D here, it's supposed to be dx and dy, at dy, dx, and then there's supposed to be cutting force, right? Cutting force here, P. Three unknowns as well, because FAB is known from the first one. Okay, three unknowns, dx, dy, p, and three equations, three unknowns and three equations. So we will be able to solve it. Okay, that's the way to solve number 5. Okay, I think that's all because it's already 12. Just noon, right? Just past noon just now. Okay. After this, I will give you another 5 number homework. Another homework, okay, for the frame and machine for your final homework in order to strengthen your concept about the frame and machine. Okay. Next week we will start with a new about new things. Okay. I think that's all for today. Okay. Thank you very much for listening. See you guys on next week. See you guys Thursday next week. Because tomorrow is holiday.
Okay, thank you very much, Pak Satrio.
Thank you, Pak.
Yep.
Thank you.
Thank you, Pak.
Sir.
Bye bye.
Pak.
Thank you very much. Thank you, sir.
Thank you, sir.
Bye.
Thank you, sir.